are 3 ways to write a vector. You already know component form. You already know linear combo form. Here's the third one. It has to do with sine and cosine. So it is going to be r cosine theta, whatever the cosine value is, and then r sine theta. So let's go ahead and explore this last one here. Remember, r stands for magnitude, theta stands for the direction angle. Remember, magnitude and direction are key critical attributes to vectors. Find the magnitude and the direction angle of vector v. We're also going to write in component form. So if you have to do like any adding or subtracting, which we certainly will on the next page, it has to be in component form. Remember, component form has a's and b's, and look at all the a's and b's in the formulas. So component form is always most important. We'll work that last. First, let's identify the magnitude. The magnitude is this 4. It just hasn't been distributed to both things in the parentheses yet. So vector's magnitude is 4. Let's talk about the direction angle. Remember, angles are always expressed in degrees. The degrees is right there. It's 120. So here's how we turn this into component form. What we're going to do is we're going to write the ordered pair for 120 degrees and then just multiply by 4. That's all we do. So 120 degrees, remember that's 2 pi over 3. And remember, your x value is going to be negative. Your y value stays positive. So I'm going to distribute that 4 to a negative 1/2 and then distribute 4 to a positive 3 over 2. So when I distribute the negative 4, it's negative 4 over 2, comma, positive 4 root 3 over 2. And then just simplify 4 over 2. So vector v in component form is going to turn into negative 1/2, that is so wrong. That is actually going to be a negative 2, positive 2 root 3. Sorry, I got to simplify my fractions, right? Negative 4 over 2 is 2. Positive 4 over 2 is 2 root 3. Let me do that again, guys. Sorry about all my mess ups here. All right, here we go. Next one. I need to find the magnitude for vector v. It's just that number in front. Again, it has not been distributed yet. So the magnitude is root 2 over 2. The direction angle, y'all, technically 3 pi over 4 is the amount of an angle, but we always express it in degrees. So remember, 3 pi over 4 is going to be in quadrant 2. So that direction angle is 135 degrees. Also, since it's in quadrant 2, we're going to take the magnitude and we're going to multiply it by the ordered pair for 135 degrees. Just distributing that magnitude. So root 2 times negative root 2, that's a negative root 2 on top. 2 times 2 is 4. Over here, root 2 times root 2 is a positive 2. 2 times that denominator is 4. So this vector in component form is negative 1/2, positive 1/2. Any questions on identifying the direction angle or identifying the magnitude? Okay, number 3, we already did number 3. Write number 2 in component form, we just did that right here. Let's go ahead and look at numbers 4, 5, and 6. So on 4, 5, and 6, we are going to find the exact component form and the linear combination form just for problem number 4 for the sake of time. And then we are going to continue on the next page with some word problems. I'm going to find exact form for all 3 for components, but only linear combo for problem number 4. All right, in order for us to do that, remember component form is the magnitude times the ordered pair. So I just need to figure out the ordered pair for 30 degrees. Remember, 30 degrees is pi over 6. So the ordered pair on the unit circle, where this is at 30 degrees, is going to be root 3 over 2 and a positive 1/2. So I'm going to take that 14 and I'm going to distribute it to both the x-coordinate and the y-coordinate. So again, guys, 14 over 2, those are going to simplify to 7s. So the component form is going to be 7 root 3, 7. And remember, it's so easy for linear combo form, that's why I'm only writing it one time. You just put those letters I and J next to the A and the B. All right, let's go ahead and practice a couple more times, because converting to component forms is kind of a big deal. It's a big thing we need in our toolkit. 4 pi over 3. All right, 4 pi over 3. Remember, if it ends in a 3, it starts with a 1/2. However, 4 pi over 3 is in quadrant 3, so both of them are negative. Just going to distribute that 5. 5 times a negative 1/2 does not simplify, it's just negative 5/2. 5 times positive root 3 over 2, nothing cancels out when I multiply those two together, so it's going to be positive 5 root 3 over 2. And I apologize to you because my y-coordinate should be negative because it's in quadrant 3. So everything is negative when it's in quadrant 3. All right, next one. 315 degrees. 315 degrees is in quadrant 4, and that matches 7 pi over 4. So we know it's root 2 over 2. It's going to stay positive for the x value, but in quadrant 4, the y value is negative. So that's the ordered pair. Y'all, we got to distribute the 6. The 6 and the denominators of these 2's, those are going to cancel out. So component form is going to be positive 3 root 2, negative 3 root 2.